Hi, everyone. I'm Rick Hennigan, developer at Wolfram, working on AI-based products. Today, I will be talking about computation, augmented generation, and MCP. So computation augmented generation, which we're calling CAG for short. I'm gonna kind of build up an explanation of what that is, what it looks like, and then I'll go over the products we're releasing as APIs that are based on that coming soon. I'll also be talking about Agent 1, which is another API offering, which is essentially an LLM API that does everything we'll be talking about with CAG, just automatically. You don't have to set anything up. And then I'll be covering our support for MCP, which you may have heard about if you've been following this space recently, and showing how you can set up MCP servers running Wolfram tech for whatever client you might be using. So computation augmented generation, CAG, it's based on the idea of retrieval augmented generation, but there are some key differences that I'm gonna go over. So to compare it to RAG, retrieval augmented generation, this is something where basically you use a way, typically with something like semantic search, to automatically find relevant information to feed to the LLM so it can give accurate answers. As an example of this, Notebook Assistant has something to provide it with information for the latest documentation and resources and things like that. So here's an LLM prompt generator that's similar to the one used by Notebook Assistant. And I can show what the output of that is. And one thing to keep in mind, that what this produces, the text it produces, it's meant for LLM consumption. Like, this is not something to give to humans. It's something you give to the LLM so it can actually give accurate answers. So the input is the context of like what the user is asking, or it could be a full conversation. And what it spits out is information that's retrieved from documentation. In this case, it pulled something from the Packlet repository. What it looks like in practice, I have these already evaluated just to save time. I ask that same thing with LLM synthesize. I use that prompt generator and it knows the answer. It knows that there's this Packlet repository function that you can use, and it knows how to answer that. So that's the idea of retrieval augmented generation. You have these fixed sets of documents that you split up into little chunks that contain the information that an LLM needs to answer accurately. And then you use something like semantic search to automatically retrieve the ones that are probably relevant. And then the LLM can use that information to answer more accurately. As a quick side note, if anyone's kind of following along and they are trying to write this stuff down to figure out how they can implement this stuff themselves, this is actually going to be available soon, soon, where you can basically say the LLM evaluator you want is Notebook Assistant, and you'll get everything that it has access to, and that'll all just work, and it'll work in like anywhere that you use LLM evaluator. It's not available yet, but it will be soon, so hang tight. Okay, so CAG, on the other hand, this is not just fixed content you're using as the source to inform the LLM about facts that it should use to generate responses. So here's a new one, which Notebook Assistant isn't using this yet, but it is being used in places that I'll talk about later. What this does, and again, this text is meant for the LLM to read to inform its response. This isn't something meant for human consumption, but you can see, you take a user's question and you feed it in there, and it automatically pulls in relevant Wolfram Alpha results. So it figures out relevant queries that should parse with Wolfram Alpha and gets a text-based representation from those, and it can have multiple. So from that one prompt, it didn't just generate one Wolfram Alpha result, it can generate several. So sometimes you might be asking a more complicated question that requires maybe multiple Wolfram Alpha queries. This is a way where it can just feed them all to the LLM in one shot. So using that with LLM Synthesize, I can ask that question, and it can give me a factual answer. And it'll cite its sources here as the Wolfram Alpha URL. I could click on it and verify that it didn't just make that up. So someone that's familiar with this stuff, the idea of like tool calling, for example, we've had Wolfram Alpha as an LLM tool for a while. Like you've always been able to give an LLM the ability to write a Wolfram Alpha query and get those results from Wolfram Alpha. And this is actually quite a bit different from that, because with tool calling, you're relying on the LLM to make the decision to call the tool. LLMs frequently are overconfident in what they know or what they think they know, and it decides to call the tool. So what you often have, the LLM will think it knows the answer to it, and it decides, oh, I don't need to call Wolfram Alpha. I'll just say the answer. And oftentimes it's wrong, or it might be saying something that's out of date, or because it's training data, it might be old, something like that. And then if you actually care about the answer being correct, you then have to do a bunch of extra work to actually verify that it gave you the right answer, in which case that eliminates the usefulness of the LLM. So this CAG context generation kind of gets around that by, and here's an example of how just relying on tool calling doesn't always work. So, here's an LLM tool that calls Wolfram Alpha, and I ask a question that Wolfram Alpha knows, and the LLM thinks it can just answer that without it. So we look at it, and it looks plausible. It gave me some information here. I can't really scroll. Oh, here we go. Yeah, so it looks plausible, but do I know if these are actually accurate? They might be, but I don't know. But if I looked at the actual output of what it did, I can see that it didn't actually make any tool calls. So I know that it's just making up that answer from whatever training it's had. But with CAG, you ask that same thing, and there isn't any choice involved with the LLM deciding whether or not it's going to use Wolfram Alpha. It just automatically sees those results before it even starts answering. So then it gives me these numbers, and then it tells me how it knows that. And I can verify those right here. So the task of actually verifying that it did the right thing is very easy here. If I want to look at the prompt text, like this is what was actually sent to the LLM, I can see that it got this relevant Wolfram Alpha information, and then it got the question from me. So how we're offering this sort of thing externally, we're going to be launching CAG component APIs as a way, if you're building an application, let's say outside of Wolfram language, but you want to give it the power of Wolfram Alpha, Wolfram language evaluation, things like that, this is kind of how you would do that. So the same context generators that I just showed, this is just a helper function, by the way, calling, and this isn't available yet to the public. It's coming soon, but we do have an internal build working. So I'm calling that API here with that same question as before, and you can see that the type of information it returns is exactly the same. It's encoded in JSON here, so it looks slightly different, but it's effectively the same. So this is something you can use in whatever application you're building for LLMs to do that sort of thing that I just showed. And we have the same thing for that documentation generation, the same exact thing used by Notebook Assistant that will now be available anywhere in whatever applications you're building. So even though the idea of tool calling isn't new, we've actually deployed APIs that are meant to be hooked up alongside these context generation APIs. So there's already been an API where you could do Wolfram language computation. This one, there's some things that are different about it. It's really tuned for working with this Wolfram language hints endpoint. So there'll be a lot of things in the output of this that instruct the LLM how to do things with this compute endpoint as well. So they're really meant to be used together. And similar with the Wolfram Alpha endpoint. So this Wolfram Alpha context endpoint will give you Wolfram Alpha results, but it can also suggest hints of things to try with the Wolfram Alpha query tool directly. So these four things are what we're calling the CAG component APIs, and you can use these to build Wolfram intelligence directly into whatever LLM application you're building. Okay, so then suppose you want to build an LLM application, let's say a chat application, whatever, and you want to give it all these powers that I just talked about. If you want fine control over it and implement it in the ways you want, you use the CAG component APIs and you have your own LLM. If you don't want to do all that and you want something simpler, we have what we're calling Agent 1. This is basically, this includes an LLM. Again, this is not the real URL. It's not out yet, but it works just like a lot of LLM APIs that you might be used to already. So the same type of format of what goes in and the same type of data that comes out. So this one, I didn't have to specify anything about CAG endpoints or anything like that. I'm just calling an LLM that uses this stuff behind the scenes, and you don't need to configure that at all. So if you have something like, if you're building something that's, let's say, currently calling like an OpenAI model, you can just drop in this one as a replacement, and now it'll just automatically know how to do all this stuff. And that's an example of what it looks like. So as an example, I've set this up for LibreChat, which is just an open source chat application that can connect to all kinds of different services. The config file for it, all I really had to do was say, what the name is. I pointed it to the URL. I gave a model name. This stuff is actually optional and isn't necessary. But that's it. But because LibreChat is already set up to call OpenAI endpoints, this was trivial to make it also work with Agent 1. So you don't have to do much extra work to make your application work with it. So I have an example of it running here. And one thing to note is that it's kind of like a reasoning model, which you might be familiar with, where you have this sort of thinking output where it's thinking about how to answer the question. The difference is this one isn't doing its reasoning with text, it's doing it with computation. So this will take a little longer than asking something like, a regular chat model that just starts answering immediately. But you'll get these results that you can verify are actually correct. So I can check the source, went to Wolfram Alpha. I saw that this is what it saw. Good. I know that that's correct. Some other examples. This is kind of similar, but like I mentioned before, that Wolfram Alpha context can sometimes generate multiple results. In this case, it used several of them to figure it out, and I can check each of them here. It's multimodal as well, but also it can compute things with things like images that you feed in. So again, when setting up LibreChat, all I did was point it at the URL. I didn't have to say anything else. And it's set up to just work as a drop-in replacement. This is a placeholder image. This will probably look different at some point, but it's able to send in multimodal content. Not only could it see it, but it can compute with it as well. And you can actually click on any of those tool calls, and it'll show you a notebook of what it actually computed. So you can at least check to see if it made up an answer, if it does Wolfram language evaluation. In this case, it's obvious that, well, it's fairly obvious that it did the right thing, because otherwise it wouldn't have an image to be able to link to here. So that's agent one. There's a lot more I could talk about with what that's capable of, but in the interest of time, I'm going to move on to MCP. So this is pretty popular right now. So in the world before MCP, you have all these applications, like, let's say, for example, Claude Desktop, which is a chat application that runs on your computer. And if you wanted to hook that up to something like Wolfram language evaluation or Wolfram Alpha, you couldn't really do that as a consumer of that application. Anthropic would have to do that on their end first. And the same goes for things like Cursor or Visual Studio Code or whatever. You couldn't, as a user, just easily hook those up to a new service. MCP changes that by making a standard where servers can say, these are my tools, with instructions of how to use them. And if that program implements MCP correctly, then you can just add in these different services to your LLM-based application after it's been shipped. So the users can do that. The developer of the application doesn't need to do anything else. So it's just a convenient way. These are some examples of things that support MCP as clients, like Claude Desktop, I mentioned before, is one of them. LibreChat. There are IDEs that you might be familiar with. These ones are pretty cool, command line coding agents, where you can basically give it a programming task and it'll go off and do it. With Wolfram MCP, it's pretty impressive what it can achieve if you're doing, let's say, Packlet development. So we have two types of these coming. So remote is probably not the one that this audience is interested in. This is for people using things like Claude Desktop that want to have it give more factual information, but they don't have a Wolfram kernel installed on their machine already. So remote will just be very easy to set up, but it's running everything remotely through those CAG APIs that I talked about earlier. And it requires a subscription to use. And because these things are running in cloud kernels, you don't have anything running on your local machine. So again, I don't think this is necessarily what this audience is interested in. The local one, on the other hand, if you have a Wolfram engine installed on your machine, this is really what you want, because you can give things access to your files for creating reports, whatever. You have persistent kernel sessions, so you can have your LLM build up more complicated computations by reusing definitions and things like that. You can do a total DIY approach where you write all your own LLM tool expressions that do whatever you want, whatever you can imagine and write yourself. You can expose those to any LLM-based application that supports MCP. And this one doesn't require any sort of subscription, but the default MCP server, like if you're not writing your own tools and you just want the Wolfram MCP server, it'll work better with an LLM Kit subscription, because those context prompt generators I talked about before, those use an LLM in the loop. So LLM Kit is used to make those LLM calls. So MCP is awesome because it's very convenient for after an application is shipped and you as a user can plug it into something, but it's not going to be as powerful as if you were designing and writing something yourself that utilized the full CAG capabilities correctly. So MCP doesn't have anything that is like LLM prompt generator, where you're taking the context and generating facts to the LLM before it starts responding. This is a big limitation, but you can get around it with MCP, but it's just something to be aware of. So you kind of had that issue where it might decide not to use your tools. So you need to tell it that that's what you want it to do. And there's ways to do that persistently in a lot of these applications, like the IDEs and the coding agents usually have like an instructions file where you can specify these things. Cloud Desktop gives you a way to set persistent instructions, things like that. But it's just something to keep in mind. Like, you might need to prod it to do what you want a little bit more than if you were building something up using CAG in its full power. So examples of it in action. This is, by the way, I should mention the local. This is how you get the local version of the MCP server. It's on the Packlet repository. It's Wolfram/MCP server, and these Packlet symbols I'll be using are from here. So here's an example where I'm installing the default Wolfram MCP server for Cloud Desktop. It tells me that it correctly set that up, and then when I use Claude, I can ask a question like this. It gets information from Wolfram, and this Wolfram context tool, by the way, this combines the related documentation and the Wolfram alpha results into one, and it sees all that information in here, and again, it cites its sources so you can verify that it's correct. So IDEs also supports Cursor and Visual Studio Code as simple installation commands. There are variations of MCP servers you can install with this, a few named predefined configurations. So this one is focused purely on Wolfram language. It doesn't include the Wolfram alpha stuff. It also includes a couple of extra tools that are really meant for like Wolfram language developers. This is the type of one you'd usually use with an IDE. So here I am using it in Cursor. I actually have it here. I was asking, so I have this Packlet I've been working on where I'm working with colors, and there have been a lot of changes lately with dark mode. And I was asking, what do I need to do to ensure my colors work well with dark mode? And this is an example of one of the things I have to say when I'm using MCP. I say check Wolfram context, because otherwise it would probably try to make something up. And it gave me actually pretty good answer here. Some things that actually I wasn't aware of because I haven't been keeping up with the dark mode stuff. And I know this is something I'm going to need to do to make my code compatible. So this is really useful and some information that I'm actually going to be using as I update that. Now, coding agents. This is one I actually use quite frequently on my Packlets that I work on in my spare time. There isn't a nice, simple install command for Cloud Code, but this here, this JSON configuration property, that's something you can just paste into a JSON file in the right place for Cloud Code to be able to read it. So this is my Packlet I'm working on, and I'm just dumping this JSON configuration to the right place. And I start up Cloud on the command line. I verify that the Wolfram MCP server is working. I can see that's 4 tools, running a Wolfram kernel, things like that. And I can say, run my tests for my file and investigate failures. I can see it starts doing things. It starts running Wolfram Language Evaluator, running some code at Packlet directory load of my Packlet. It gets the context, runs a test report, and checks the tests that failed. And then once it sees that there were failing tests, it uses that Wolfram language context tool to figure out that it needs the most recent documentation available, because you don't want to just start assuming how to fix the problem. And you can see one of the first results, this is truncated here, but you can see it got documentation about quantity array, which was related to the bug I had in that test. And so this was actually a real example I did yesterday. I got Cloud Code to fix the bug, make a few updates. It wrote this pull request for me, which is pretty convenient. I can see the commits that it made in here, along with some of my updates as well. And this is the whole process that was right here. It didn't require much input from me, but doing this type of thing, which I tried to do a few times before MCP with the Wolfram MCP, it was hopeless. It just wouldn't work. So this is really a game changer here, if you're using these kinds of tools. And you do need to kind of get a sense of what the LLM is actually capable of. It's not going to do, it's not going to understand your code base as well as you. It's not going to be able to come up with new ideas and do high level things, but a lot of the busy work involved, you can very easily offload onto an LLM. So, and you get a sense of what it can and can't do, and you just don't waste your time trying to ask it to do things that an LLM is just going to fall over with. But that just comes with trying things and see what works and what doesn't. But that's what I have. So I'll be taking some questions here. So first question, in order to have CAG, do you need to have a special parser or named entity recognizer? No, you do not. So the input of these things, so I'm calling this API, you just feed it context. So in this case, I'm just using a string, but what makes it even more effective, which is optional, you can actually just pass it the conversation containing the messages, like the same type of thing you'd send to an LLM API. And it works even better. But you don't have to do anything with this text. You just throw it at the API and let the API figure it out. So there's no need to figure out what entities there might be in there, things like that. That's all done server side. So if you just, there are things you can do in your code to decide whether or not you want to make this API call. Like let's say you have some heuristics figuring out if it might be a computational type of question. You can certainly do that, but if you don't want to and just send everything, that works as well. So the next question was, we've seen some impressive things such as computing protein folding. Would be calling a tool to compute how proteins fold be a natural candidate for CAG? I don't know enough about that to answer. If it's something that Wolfram Alpha knows about, or there's relevant information in our documentation, I would say yes. I don't know enough to be able to answer that, though. So the next was, in the evolving world of LLMs, much continues to be opaque. So Stephen showed that we've been collecting metrics on LLMs. I think you're talking about the LLM benchmarks that we do. We're doing anything to help with objectivity, comparing Wolfram language LLM kit. So there's a lot of things we're comparing that are kind of hard to put into benchmarks and come up with, these numeric scores. So the benchmarks that we're publishing about how much syntax they get correct and whether or not they're writing correct code for these certain things, it's really a very simple thing that we're testing. And I don't think benchmarks tell the story that we really care about, because you can just take the model out there that's performing the best on benchmarks and try to apply it to a real application and try to do something novel, and it could totally fail. Benchmarks aren't showing you things like how well do they follow long, complex instructions? How well do they understand interfaces and user perspectives? Like, one thing to make Notebook Assistant work, the LLM has to understand, for example, that the text it's seeing isn't necessarily what the user is seeing, because the user is seeing a richly formatted notebook environment, and the LLM is seeing a text version of that. And it's kind of important for the LLM to understand that. That's an area where, for example, Claude models might be, the quote best coding models out there. They're unfortunately not the best Notebook Assistant models, because that's something where they kind of struggle. And there's a lot of stuff that's really hard to quantify that you need to check. So there's always things that we're looking at and comparing, and we're objectively comparing some benchmarks with the syntax check and the code correctness, but that's one tiny piece of the puzzle. For getting a really good sense of what a model is capable of for your application, you really just got to spend some time with it. So the next question is, can MCP be run on a server? Yes. The implementation for these clients are wildly different, though. Like Cloud Desktop, for example, requires that the remote MCP server do authentication via OAuth 2.1, which I think isn't even finalized as a standard yet. So we don't have a way of cloud deploying something that would work with Cloud Desktop, but we can deploy something that works with OpenAI's MCP implementation, LibreChat, a couple others, but the remote support out there is far less mature than running something locally. So this packlet that I've been showing doesn't yet have anything for deploying these to the cloud, just because it's so wildly different for these different clients. And I kind of would like to see that settle down a bit, but it is possible. And maybe I could post something in community or something that shows how to do it for certain clients. Will you be sharing your slides? Yes, I will be uploading those soon. And I think that's all the questions, unless anyone had any others. Okay then, well, thank you everyone for coming. And again, I'll be uploading these slides so you can kind of go over more details. I know there's a lot here, and especially the context generation stuff I might have gone over through a bit quickly, but I think if you play with the examples, it'll be more intuitive. But yeah, thank you everyone for coming, and see y'all later.